So as you can see, the current is displaying here is 63.0. The trick is, this device actually comes with the maximum current rating of 63 amps. So it therefore means that, if just in case you do not find the manual to set, so you don't know the setting number for the particular product of AVP you have actually bought, what you just simply need to...
Okay, welcome to Ben-Omo Electrical Company Limited. Today I'll be giving you a tutorial on how to make use of this automatic voltage and current protector, also known as AVP. Yeah, so it's a amp and voltage protector, AVP. So these two devices actually up here at my front, as you can see, it's two pieces of AVP and a socket. Yeah, so these both AVP are actually the same. They perform the same function. So I'll be making use of one of these AVP to get this illustration done. So up here, I will be making use of this very AVP. So we'll unbox it right now and then make use of it. So right here, we connected this socket to this AVP, and then this AVP is connected to our power supply. So we'll be powering up this AVP right now. So as you can see, we've powered it up, and right now it's turned on. So yeah, so it's reading the voltage at the top, and then the current at the bottom. So but right now, because there's no current drawn, no load on it, it's reading zero.
So setting it such that it doesn't exceed the particular power rating. So on this device, we do not have the parameter of wattage, but then we have the parameter of current. Now what do I mean? Doing this, we just move straight to the parameter we're actually looking for, which is, this device actually has a maximum current rating of 63 amps. So whichever device you actually buy, that's whichever of them you actually get on the long run, just move on to the parameter that gets you to parameter 63, that gives you a value of 63. So this is it. I'll keep pressing set until I get to 63. That rating on that 63 means the current, because don't forget I said this device has a power rating, a current rating, a maximum current of 63 amps. So we just move on to the major thing we're actually looking at for, which is the current rating. So this is the current actually that this device can actually permit. So what we'll do is that we'll alter the value. But to what value should we alter this current rating to? So for this device, it's P9, option number 9. For this very product, it's actually option number 9. So we'll be altering this to a particular value. But then, what is the question? The next question is, what value should we alter it to? Then the first question we should ask ourselves should be, what is the maximum wattage you want to achieve? Okay, so that brings us to the use of a pen and a paper. So first, the question we ask ourselves is, what is the maximum watts we do not want to pass through the device? So what is our maximum wattage we're actually looking for here that we do not want to pass through this device? So let's assume a wattage of about 250 watts. For example, our inverter is so small that we do not want any power rating of above 250 watts. So then our first parameter here will be maximum watt. Our maximum wattage, don't forget the unit should be 250 watt. 250 watt. So now this wattage is actually our power rating, our maximum power rating. So the next thing we'll ask ourselves is, what is the voltage at this very point in time? What is the voltage? So up next, we'll be making use of our multimeter to get this done. So right now, this is my multimeter, and then the device is over here. So but then, even on the device, it displays the voltage right here on this device. So the voltage being displayed on this device is 220 volt. So this top section is the voltage, while the bottom section is the current. So right now, we are not engaging this device right now. There's no current drawn because there's no load on it. So the voltage at this point is reading 219 volts. So let's just confirm that using our multimeter. So confirming that using our multimeter, as you can see, 219 volts. So it means it collocates, it's accurate. So we'll take our voltage. So coming over to our pen and paper, we'll take our voltage to 219 volt. So our voltage at this point is equal to 219 volt. So then that brings us to a formula, which is the power formula. The power formula, the unit of power is wattage. So power is equal to current times voltage. So I here means current, then V here means the voltage. So for us to get the current, don't forget, on our device, the only parameter we can alter on this device is the current, which is on P9. It is the current that we can actually alter. So the voltage is there at this very point in time. The wattage we're trying to, the maximum watt we do not want to exceed is 250 watts. Yeah, so that's the power. So we'll therefore make use of our current the subject of formula. Yes, in doing that, our current I is equals to power, of which the unit is wattage, divided by what? Voltage, of which the unit is V. Voltage, V. So right now, what is our maximum power rating? Our maximum power rating here, as you can see, maximum wattage. So our maximum power rating is what? 250 watts. Divided by, what is our voltage? Our voltage at this point is 219 volt, 219 volt. So if you do this with your calculator, what are we going to get? We're going to get a current rating of 1.1 amps. The unit for current, I, is ampere. So our current rating should not exceed 1.1. So actually this value is 1.14155 and so on. So but on this device we can only set to 1 decimal. So if we approximate this, since it's not up to 5, we can round it up. If we approximate this, we can round it up because it's not up to 5, so we just pick 1.1 amps. So it means that our current that we're going to set should be what? 1.1 amps. So now coming back to our device. On this our device, we already know that our parameter for current is on P9. P9, setting P9. So we'll scroll down over to P9. Okay, so right now we're on setting P9. So this is setting P9. We're on setting P9. So as you can see, the current is displaying here is 63.0. The trick is, this device actually comes with the maximum current rating of 63 amps. So it therefore means that, if just in case you do not find the manual to set, so you don't know the setting number for the particular product of AVP you have actually bought, what you just simply need to do is that keep pressing the set button. Keep pressing the set until you get to the maximum rating of this very AVP you have bought. The maximum rating of this AVP we have here is 63 amps. A lot of them are 63 amps. So right here, you see that all the things we've been pressing, all the settings we've actually been going through, none of them have 63 as their figure, as their factory figure, but except this P9, 63. So it means that this is the current rating. So up next, we'll reduce this value down to our 1.1, which we've actually calculated. We'll reduce this value right now down to 1.1. Yeah. So here we're almost getting to 1.1. Okay. So this is it. So we actually set the current parameter to 1.1 amps. So this is the current rating, 1.1 amps. Yeah, 1.1. So right now we'll subject it to a load, a light load. We'll go gradually and see how this reading actually goes on. So I'm going to put a load of about less than 100 watts, and then I'll increase the load, and then we'll increase the load. So this is actually my socket that has been connected to this AVP. So this very plug head here is an extension wire. So I'll go on and on different appliances I have actually plugged on this external wire. So the first thing I'll on there is a small fan, then a small standing fan. So I'll be turning that on right now. So let's see what happens. So as you can see, it's beginning to read, but then the reading is small. So yeah, so I'm taking it higher. So as you can see, the reading on this, based on the load currently, the current load is 0.5 amps. I'll move on to increasing the load actually on this, and let's see if it trips off. So first, let me off the fan and subject it to a higher load. So let's see how many amps is it drawing. It's pulling an amps of about 0.8 amps. Yes. So the next load I will increase, will then increase it. Let's see. Immediately it exceeds the 1.1 amps. What happened? It tripped off. Now it tripped off and then began to count a particular value. This value it's counting is reading from from about 30 downward. It's actually the overcurrent reset time. It's called the overcurrent reset time. So what happened? Since we set the current rating to be 1.1 according to our specification of maximum wattage. So you see, each time it exceeds, it goes back to count for 30 seconds. Once it exceeds our rating, what happens? It trips off and counts for 30 seconds. As much as it comes on, and then it notices that the current rating is still on the high side, what happens? It trips off again. So based on our calculation, based on the maximum watt we are trying to not exceed, as you can see, which is the 250 watt. So we were able to get our current rating of 1.1 amps. So by doing this, we have set this meter not to permit any wattage of about 250 watts. So thank you very much for watching. This is Ben-Omo Electrical Company Limited. Do well to subscribe to our channel, like, comment, share, and do well to give us a thumbs up. Thank you very much. Do well to subscribe. Thank you.